Niels Bohr was the scientist that did the work to establish our current understanding of electron structure. He said that electrons orbit the nucleus in discrete shells, which are specific distances away from the nucleus. He said that the electrons in an atom occupy the lowest available energy level, which is another way of saying they occupy the innermost shells that they can. We can represent the electronic structure of an atom using numbers or by a diagram, and in order to draw those, we need to have an appreciation of the 288 rule. Basically, the 288 rule tells us the maximum number of electrons that can be held in each of the shells. So, for example, the first or innermost shell can hold a maximum of 2 electrons. Once that is full, electrons go into the second shell, which can hold a maximum of 8 electrons. And once that is full, electrons will go into the third shell, which can also hold a maximum of 8 electrons. So therefore, when we're drawing electron structures, we take two things into account. First of all, we make sure we fill the innermost shells first, and secondly, we make sure that we don't overfill them according to the 288 rule. So, let's look at a couple of examples. Sodium has an atomic number of 11, which tells us it has 11 protons. Because in an atom, protons equals electrons, we therefore know that sodium has 11 electrons. Let's start putting them on shells. The inner shell will take 2 electrons and be full. So at that point, we'll move on to the next shell. We can totally fill that shell as well, because that holds 8. And 2 plus 8 makes 10. And then we'll put another shell on with just 1 electron, giving us a total of 11. This is the diagram form. We could also write it as the numerical form 281. You need to be able to write the electron structures of the first 20 elements on the periodic table using either the diagram form or the number form. So to make sure you understand, we'll look at another couple of examples. Hydrogen has an atomic number of 1. So again, we know it's got 1 proton and therefore 1 electron. This therefore makes it a very simple electron structure to draw. We're going to have the innermost shell with just 1 electron on it, and the numerical form is a number 1. Calcium often causes confusion for students because of the number of electrons it's got. We know it's got 20 protons, and hence we know it's got 20 electrons. If we start following the 288 rule drawing the diagram, the innermost shell uses up 2. The next shell takes 8, bringing us up to a total of 10. The next shell holds another 8, bringing us up to a total of 18. But we need 20. The reason students get confused is because they've learnt the fact that it is the 288 rule. They forget that what that means is that the first shell, the second shell, and the third shell have got limits. What it doesn't mean is that you can't have a fourth shell. And in order to give calcium 20 electrons, that's what you have to do. You give it a fourth shell with 2. That means that the numerical structure for calcium is 2, 8, 8, 2. Now, a lot of people at this point will say, so how many can the fourth shell hold? You don't need to worry about that, because once you get above calcium, the way that we draw electron structures is very different. You're not going to get anything bigger than calcium, so as long as you remember that you can put a fourth shell on, then you will be absolutely fine.